Let's look at taking derivatives of these complex functions. If it is more than just x to a power, we're going to use the chain rule. If we have x's divided by x's, we're going to use the quotient rule. And those are the two rules we see in numbers 16 through 19. So looking at this first one for number 16, I have a root, so I know I'm going to rewrite that. Whenever we see roots, they become fractional powers. It's a square root, so it's really a 1/2 power. So this is x to the 8th minus 8x minus 8 being raised to the 1/2. So this is our chain rule, more than just x to a power. I'm going to start by bringing down that power. So the 1/2 is going to go out front. And I'm going to subtract 1 for the new power. So 1/2 minus 1 is a negative 1/2. The original is going to be raised to our new power. So bring down that power, subtract 1 from the new power, put the original back on the inside. And now we're finally going to take the derivative of what's inside. So looking at x to the 8th, it has a derivative of 8x to the 7th. Derivative of negative 8x is negative 8. And derivative of that minus 8 at the end is 0. Remember, you want to multiply by the whole derivative of the inside, so it does need parentheses. So bring down the power, subtract 1 from the new power, multiply by the derivative of the inside. Looking at the next one, I have x's divided by x's though. So I don't have to rewrite anything because I have x's divided by x's. I'm just going to use a different rule. I have the quotient rule. There's lots of ways to say the quotient rule. I'm going to take the derivative of the top, the original bottom, minus the derivative of the bottom times the top, all over that original bottom is getting squared. So looking at the derivative of the top to start, the derivative of 1x on the top, derivative of 1x is just 1. Derivative of the top gets multiplied with the original bottom. So we have 3x to the 5th plus 4. Minus, now I'm going to take the derivative of the bottom. So we have 3 times 5 is going to give us 15x to the 4th. Derivative of 4 is a constant, so it's 0. So I just took the derivative of the entire bottom piece to just be 15x to the 4th times the original top, which is an x, all over the original denominator squared. 3x to the 5th plus 4 gets squared. I can go through and check that I have each piece. Derivative of the top, original bottom, minus derivative of the bottom times the original top, all over the original denominator squared. So we have all of those pieces of our quotient rule and we are good to go. The next one is 10 divided by x to the 6th minus 9 to the 5th. It is not x's divided by x's. So anytime we have just x in the denominator, we've been rewriting it, right? If it was 10 over x squared, we would never use the quotient rule. We would just say, okay, let's bring up our negative power so that we can take the derivative of it. We're going to do that same exact thing here. We're going to rewrite instead of using the quotient rule because there are not x's in both the top and the bottom. So I'm going to keep that 10 from the top. And this is really x to the 6th minus 9, and it's to a negative 5 power. Now it is looking like a chain rule. So much faster than the quotient rule. It's nice when you don't have x's in both the top and the bottom. We're going to do the same thing that we just did above in number 16. So we are going to bring down our power. 10 times negative 5 is going to give us negative 50. Bring down that power, negative 5, and subtract 1 for the new power. So negative 5 minus 1 is negative 6. We're going to copy down the original inside, x to the 6th minus 9. So we brought down the power, subtract 1 for the new power, and then we're going to leave some space to multiply by the derivative of the inside. The derivative of x to the 6th is going to be 6x to the 5th. Derivative of negative 9 is 0. So there's the whole derivative of the inside. And we're going to do that same exact thing one more time. I have 12 over the square root of 8x squared minus 3. This is not a quotient rule. There's not x's in the top and the bottom. I'm just going to say this is 12 and bring up that negative power. it is 8x squared minus 3, and it's to a negative 1/2 because it was under a square root. So we rewrite that power just to take the derivative of it, which means bring down the power, subtract from the new power, multiply by the derivative of the inside. This is another chain rule. So these last ones look like they could almost be quotient, but if it's not x's divided by x's, we get to use the much faster chain rule. So I'm going to bring down that power. 12 times negative 1/2. Half of 12 is going to give us 6, so we have negative 6 here. Bring down that negative 1/2 power and subtract 1 for the new power. It's going to be a negative 3/2. Now I'm going to copy down that original inside, 8x squared minus 3. And last part of the chain rule, after you bring down the power, subtract from the new power, you multiply by the derivative of the inside. The derivative of 8x squared is 16x, and the derivative of negative 3 is 0. So we just did 3 chain rules and 1 quotient for numbers 16 through 19.